So my name is Jared. I've been a developer at Big Compass since I graduated about 3 years ago. And for the last 2 years, I've been their MuleSoft developer. So what I'm going to cover today is why we test our code, how we test our code, and lastly, I'm going to do a demo on the main components that we use in MUnit and how they're used and what they're used for. So to start, why we test. You can have good and bad goals for forming your tests. Some proper goals to start with. So verify that your code satisfies many types of requirements. If you can assert a requirement, then you can almost be happy that your test set helps you satisfy those requirements. For example, if you have a request to an API and you get a response back, you do some transformations on it, well, you can have an assertion at the end for your test saying that those fields are present, that they have the right values, it is what you expected. You can verify that future code doesn't introduce the same old bugs that you've already tested for. So for example, if you have an assertion that passing 0 to a divider should, then even if you change what you're dividing, even if you change what you're doing with the response afterward, if you still have the check that you cannot pass 0 to the divider, then you can be sure that you don't introduce that same bug. And lastly, it encourages us to think about edge cases. So a really good goal to have when you're testing is to start testing your code as you're developing it so that you can start thinking about what can go wrong in your code, what most likely won't go wrong in your code, and see if you're actually solving the problem in the right way. What testing can't help with, though, is, well, you can't ensure that new classes of bugs aren't introduced. So for example, if I have a request to Google and I add a transformation after I write the test, well, that old test does not ensure that my transformation will work right. I have to update the test. I have to doctor the test and make sure that I handle that transformation and any bugs that can introduce separately. And that needs to be an update to your test. It doesn't ensure that the outside world will work. Google can change their response format. Google can be down. It doesn't happen often, but whatever API you're hitting could just be down. And a test is not going to ensure that it's working. In fact, your own internet may be down and you can run any of your code normally because it just fails on every request. And you can't ensure that you're actually solving the right problem. So basically what this is saying is a test can't fix bad acceptance criteria or bad requirements. If your requirements say that the customer wants all their Facebook posts, but your client actually wanted all their Twitter posts, your test is not going to help with that. All your test is going to do is make sure that the requirements you were trying to satisfy get satisfied. Next is how we test. What tools does MuleSoft give us with MUnit so that we can write good tests that help us? Well, they give us the capability to set things. So for example, if I have a flow that has a database query and that query expects a parameter, say an ID, well, when I run the test, the variable is not going to have been set anywhere. If you're calling that flow that has the database query, it expects the variable to be set before you enter the flow. So what you can do is you can use a setter to set the variable, and the way MUnit will work is it will set the variable itself, then call the flow, and the flow will be able to pick up that variable. And that means that you can set it to whatever you want. It's very easy to change it. And that allows us to basically have an initial state that we start running a test with. instead of having to build up the state within the test itself. Next, and it's very similar, we have mocking. So say, for example, that you have a stateful flow that makes a call to the outside world. Say we have a database query that returns 30 contacts, but you don't really want to rely on querying the database for every test. We have the same issue that we had with trying to call Google. Your internet could be down, your database could be down. You might not want to constantly be calling your database with calls for every time that you run a test. I mean, that sounds like unnecessary load that you don't need to actually put on it. Instead, you can mock the database, and instead of the test calling your database, you can just have that processor automatically return the 30 contacts from when you initially ran the flow. That way, it doesn't reach out to the database. You can run it offline. You don't have to worry about pretty much anything coming from the database. Heck, you don't even need to ever have actually connected to the database. As long as you can mock that response from it, you can just pretend that you're connecting to the database. And that's very, very helpful because a lot of the times calls can take a while. You can have a call that takes 30 seconds. You don't want your test to take an extra 30 seconds to make the call. That doesn't really make any sense. If you know what you're getting back from the call, it makes sense to just pretend that you made the call. And that's what mocking allows us to do. Any processor that returns a result can be mocked. Transformations, queries, HTTP calls, anything. Next, we have spying. So this is basically when you have a flow that has some kind of conditional flow control. It has multiple paths, and you want to make sure that given a certain state on one side of a control flow, that on the multiple paths on the other side, it matches what you would expect. So for an example here, say, again, you have a database query that retrieves a contact. You want to make sure that your choice condition that you have after that database query evaluates whether your contact is named Bob or not. Super simple choice condition, just looking at the name of the contact. If it's Bob, goes down one path. If it's not, just goes down the default path. Well, you can spy on the result from the query and the payload after it goes through one of the choice conditions. And if it goes through the when name equals Bob condition and it actually has the name Bob, then you know that your evaluation worked, that you didn't accidentally look for contact.id equals Bob or contact.phone number equals Bob. And you can also check that when you get Ralph from the database instead of Bob, that it goes down the default route, that your condition doesn't match. And this is very helpful when you have large choice conditions, when you have dynamic choice conditions. So say, for example, you want to call different flows based off of what contact you get. If you have 10 of those, it's really easy to spy on each result afterward to make sure that it's going down the right ones. Next, you have verifying. So say you have a flow with a loop in it, a for each loop. Well, if you have a database query that retrieves, again, about 30 contacts or so, but you only process the contacts if their name is Bob, well, you know how many Bobs are in that mocked query because we mocked it. We know exactly what it's set to. We are returning 10 Bobs in that database query. Well, you can verify that your for each loop runs 10 times, once for each Bob, not one less, not one more. You can make sure that it does it at least 10 times, or you can make sure it does it more than 10 times. You can essentially verify how many times something was called. And lastly, for the main MUnit tools, you have Asserting. This is basically a way to ensure that a payload or a variable at any point in time is a certain value. So now that you've ensured all your code is working right, let's make sure it actually creates the right result at the end. That's essentially what you're trying to do. Even if your flow has multiple possible results, you can ensure that it has the right result with an assertion for a specific input. And tying all this together and making it easy to use is the recording function for MUnit. This is a rather recent addition. And before, I know that I wrote a lot less tests before this was introduced, because creating mocks yourself, setting things yourself, calculating how many times something ran in a loop, asserting the response, all that, it wasn't exactly easy. It's not hard, but it was tedious. Having to create all these variables is time-consuming work, and at the end of the day, when you have a client paying you to get code out the door, you sometimes can feel like, well, I gave it a good iPass check. It looked all right to me. I mean, when I ran it, it was making the expected result, looked fine. But that's not real testing. That's, you think it works right. With recording, imagine being able to automatically have setting, mocking, spying, verifying, and asserting done for you. All you have to do is run your code and select, yes, I want this set. Yes, I want this mocked. Yes, I want this spied on. You don't actually have to set up any of that. It does it automatically just by watching your code run. And it's all done through a very easy wizard, and it just helps you set up all these tools. Now it is time for the demo, where all this comes together. And I'm going to go ahead and switch over to Anypoint Studio so I can show you guys this. Can you guys still see my screen?
It looks good, Jared.
Okay. So what we're going to be doing here is I have already set up a mock API. And I did need to change the script for this demo a little bit, because mock APIs actually got updated, if not today, maybe yesterday. And you can no longer, from what I can see, turn a mock API on and off in the same way you used to be able to. Instead, it is on by default. And if you turn it off kind of by making it private, if you turn it back on again, it completely changes the URL. So I can't use it in the same way. So I've mixed this demo up a little bit at the last moment. So what we're going to be doing here is we are going to first, we're going to reach out to a endpoint. And all this endpoint does is return a single person. It will return a hero. And by hero, all I mean is it will return a person with an ID, a name, a little bit of health, and the amount of damage that he does. Because today we are having a hero beat a villain. So this is super simple. All we're doing is calling the subflow and makes a request to the API and returns a hero. Now I need to change this URL just a little bit, because I tested that public to private transition. Okay. Now, all this is doing is we have a scheduler that starts immediately and then doesn't run again for a year. So I think we're safe there. And then it calls this flow, which reaches out to that mock API, gets the payload, and then we're just gonna log it just to make sure that everything is good.
Yeah, you have a double dash in your URL there.
Oh, thank you. One bad part about having one on one screen and on one computer and one on the other.
Yep. Well, now we know it's a real demo too because it failed.
Doing it live, guys. We're doing it live. Now, I get that this may be a little annoying that we are waiting for this to start up every single time so we can debug this, but that's actually one of the good things about MUnit. I noticed that a lot of people test their code by putting it in debug mode and running it through, making sure everything looks right. But honestly, you probably spend about 5 minutes just staring at your screen because it takes a little while to start up. And you have to do that every time you want to test. I change that little dash, have to do it again. But with MUnit, you can just run the single test. It starts up much faster. You don't have any problems. Give me 1 second, I'll grab my charger. I wasn't expecting to use this laptop. And I see my issue. The issue is I can't actually read because this is supposed to be a 4. I'm not sure how I got F because I'm wearing my glasses.
Might be time for a new set of glasses.
Sound like my mom.
I already have kids of my own. I don't need any more.
So assuming that this one works and we are able to log this correctly, what we're going to be doing is seeing what happens if this endpoint changes. What happens if I don't make the call correctly, or if it's down, or whatever just happened. What happens if I can't successfully make this call? And we have the response. I was able to type correctly. We're getting back our hero, Jim Kelly from the Dodgers, with 60 health and 102 damage. All right. Now we're going to test what happens if I would normally take the API down, but we're going to record this This will allow us to be able to see this flow just as if we're creating a test for it. And there we go. That is super easy. So we're just gonna keep this same name. And this is what we see. So what you're seeing here is the subflow that you recorded, and then each of the processors in here. So for example, you can say, take this request, and you can mock it, you can verify that it was called, or you can spy on it, see what was before it, see what was afterward. And you can do this with anything that generates an output. So a logger, you can't mock a logger because it doesn't return anything. What would you be mocking? You can verify that it's called. You can verify that before it has a certain result, but you're not going to mock it. You can mock this request. So we're going to go ahead and mock this because we don't want it to depend on if the API is down or not. We don't want that to matter. So this is going to create this request. Now what you're going to see here is you're going to see a mock win, and you're going to see a set input. Now we don't actually have any input into this, but let me go ahead and show you what this creates. So this will create a set event. We don't have anything, so it's going to be null. We're going to have a mock payload. So this is the payload that we get back from that call. It saves it. You can change this. So if you want to mock a different scenario, say this is not Jim Kelly, this is Bob McGee, you can do that easily and freely. You don't need to keep this the same as when you recorded it. How do I get rid of Bob McGee? There we go. Control Z is not working. All right. You can mock your attributes. So say you want to have different things based off of the headers, based off of your status code, anything like that that you get back. You can easily mock all of that here and change it easily for any conditions. And lastly, you're going to have an assert for the expression. So at the end of the payload or at the end of the flow, what is your payload supposed to be? In my case, all I did was get it and then log it. So it's going to be exactly what I got. Now, this happens even if I say, go into my meetup and say I change this to, instead of heroes, I'm going to say this is heroes 333, just a random typo. Maybe my cat sat on my keyboard, anything like that. Well, since it's mocked, it's not actually going to make that call. We just want to test what happens when the call is successful, returns the expected result, and that we handle it correctly. So I can run this test, and you're going to notice this is going to be much faster than starting it up in debug mode, waiting for everything to deploy, and then trying to manually test it. That can take a very long time. This also allows you to run multiple tests at the same time, which is very fast. So for example here, already ran the test, super easy. Whole thing only took 15 seconds. I normally take almost a minute just to start up my application. Okay, so that's easy. We can just go ahead and mock that call. Well, what happens when I introduce a new call And this one doesn't always return the same result. So I have another subflow here, and it is also going to make a request, but it is going to make a request to the villains endpoint. Now, anyone who has ever read a comic book knows that there is generally one hero for the comic book, but because he has to beat people, or she has to beat people, the villain doesn't normally appear back in every single issue. You're going to have multiple villains, so we can return multiple villains here. But that makes things hard to test, especially when you're not using mocks, because, well, if it is a random occurrence which villain I get back, because depending on which month it is, maybe the hero's fighting a new person, then you need to be able to mock that and say, I don't really care which villain I get back. I'm expecting to get back a villain. So, So I am going to add this flow reference here and say, you know what? Let's give these better names. I want to be able to say that the villain I get back, as long as I handle it correctly, it is fine. Because what I don't want to do is I don't want to have an assertion where I am expecting a specific villain, I run the test, it makes the request to the API, and I get back a different person, so my test fails. No, that's not right. What you're essentially saying there is the server that you're connecting to has some sort of outside world state. It can change, it could be down, it could do anything. And you don't want to rely on that state being the exact same every single time you run your tests. So it is much easier, in most cases, to just pretend. So we're going to see this run. Gun here. Oh, it is still trying to connect to Heroes 333. That is not the correct one. So we're going to re-record this test. I've honestly never received that error before. But it seems to also have worked. Sorry, guys, I honestly am not sure on that one. I'm going to go ahead and fix this name just in case that could have been anything. I don't see how it could have, but I also don't understand the MuleSoft gods sometimes, so. Sorry, bear with me here. I'm going to re-record this test. And it seems I keep running into resource errors. And I'm still not sure why that could be happening. I ran this multiple times already, but okay, we're gonna skip this. All it is showing that the same thing as the last one, that you can mock this call and always receive the same event back. So now we're going to add one more endpoint here. This one's going to be a post call. And we're going to have this hero of ours attack the villain. So we're going to say this is the hero. And this is the villain. Because if this changes our payload each time, we want to set these as variables if we're going to use both of them. So I'm going to create a request. And it's to that same mock API. Except this is going to be a post. And we're going to go on the attack endpoint. And then we're going to add a logger so that we can see this response. And this will be post attack. Now we're going to go ahead and record this. And what's going to happen here is we're going to get a hero, get the villain, and before I forget this, we have to actually send that hero and villain in. So instead of this payload here, we're going to say our attacker is the hero, and we're just going to send in their ID. And the target is the villain, and we're going to send in the villain's ID. Now, this has a 50-50 chance of succeeding according to the mock API. I can either get a success, and I kill the villain, it sends me back that the villain's HP is 0, or I have a failure and the villain's HP stays the exact same because my attack did not succeed. Oh, before I start that, I need to make sure that that's called. Just for reference, we're going to name these better. So that's getting the hero. That's giving me the villain. And then this is arrow attacks the villain. Use resource errors though. Since my computer is not very capable of sharing my screen and running all this at the same time. Well, Brian, I'm honestly not sure what to do here. This laptop does not seem to be wanting to work with me. And all it took was me complaining.
Yes, it's a demo gods.
Can't control that. So what we do want to do here is we're going to use those setters. So we're going to set the hero and we're going to set the villain. And then we're going to mock this processor. So here we're using a setter, we're using the mock, and what this means is this mock will always return that, yes, we killed the villain, he has no HP. Now, if I don't mock this, there's a 50-50 chance that I will get back the wrong response, that this will fail, not because I did anything wrong in my own code, but because the response from the server is random. It's a 50-50 response. So I really do want to mock this. And with this setter, I can now say, this post-attack test, and it's very simple to understand. You mock the request, which you can see here in post-attack test. You're going to see a lot because it makes all those calls before getting here. But what you really want to do is you have the two variables that you have. So you have your villain and you have your hero, and you're mocking the payload that you get back. So this success target HP is 0 because you killed them. Great. Now, if I go to this flow again, and I say, all right, that's great and all, but what if I want to say, all right, depending on if the villain is dead or not, so we're going to make that a attack result, and we're looking at the target HP. Then, yeah, we're going to say, all right, he's dead. Kill him. Otherwise, we're going to say, well, for each of his little HP, they're all going to say hi to us. So we're going to say from 1 to attack results, target HP. Make sure. Yeah, this is just because it doesn't actually know that this is a number here. And for each of those, we're going to the logger and say, I'm still here. Yes, okay, it just doesn't know. Okay, and well, this is starting to get to be quite a bit to just run on the run-on startup. We really want to be able to test this entire logic and say that, yes, when I get a hero, I get a villain, and the hero attacks the villain, all that logic works. So we're going to piece this together in a subflow down here. And then we're just going to call this. Now, what we're going to do here is we're going to call this flow to get the hero. We're going to call this flow to get the villain. And we're going to call this flow for them to attack. And then we're going to check if he has any health. If not, we're just going to say he's dead. If so, for each of his health, we're going to say that it's still there. Now, the good thing about this is that I can just go ahead and record a test for this. Oh. If I don't forget to add names to things. All right, and we have the recording. All right, pretty fast there. And now we're going to create a test for this. And we have our get hero. Let's go ahead and mock that. Don't want anything to happen if the mock API is down. Same thing with getting the villain. And same thing with them having an attack. Now, here's where we're going to expand off the mock, because I'm sure you've been hearing me say mock a lot, and you're like, well, yeah, that's only one of them, though. Well, what we're going to do here is we have a choice, which means that we can spy on this. We can make sure that this only happens if we actually get the correct result so that it goes through the choice correctly. So what we're going to look here is before the logger and after the logger. Now, it thinks we're going to mock the payload. No, we're going to mock the variable. Don't care about the villain or the hero. We do care about the attack result, though. We want to make sure that this only happens, it only goes to this specific logger if the target HP is 0. Otherwise, it'll go down the other route. And we don't care about the payload or the variables after the logger. Now we get to see the screen, this summary screen where we see what we're mocking, we see what we're spying, and we see what we're setting for the event. Now, I can run this, and it'll go through each and every time, ensuring that it goes through the proper path. And in this case, the path it's going down is getting the hero, getting the villain, checking the health, and it's going here and saying, okay, target HP is 0, go through this logger. But what if I want to test the other one? What if I want to say for each result or for each HP, I want it to be logged, and I want to verify how many times it logs? Well, we can go to this MUnit suite, and we can just duplicate this. Now, all the names are nasty because of the copy ofs, but ignore that for now and just think of the logic here. So it's going to use the same post-attack test because I just copied everything, which means that it references the same thing. Normally, what you would want to do is change all of these so that it creates it pulls it from a new post-attack test. All that means is you're going to go in here, copy, paste, yes, save. And in all of these mocks, you're just going to change. Sorry, this is the try to kill test, but you're going to change this to try to kill test 2. Same thing here. This is just going to become try to kill test 2. And what we're going to do is in the new one, we're going to say, all right, well, I really wanted to actually test that for each. So what I'm going to do is I'm going to say this, where is it? This variable that we receive, instead of a success true, we're going to say this failed, and that it still has 60 HP. What this allows us to do is record a test once, and then we can change it around to see if we get the same results. So this should fail now because when I run this test, it's going to try and go through that same logger, but that's not going to happen. Instead, it's going to go through the other one because it wants to go through the for each, which means that it'll fail here on the spy. And we see there it fails. Now that happens because this spy on the logger doesn't get this assertion. This assertion does not pass because the variable that it expects to assert on isn't right. So what we can do here instead is we can go back, go to our code and say, all right, I'm going to go ahead and change the mock API to return a failure. That way we know exactly what we're getting. And re-record this test. That way it'll go through the for each. And we'll be able to test out the verifier. And we can see for each one, it's saying, I'm still here. Got back a success false, target HP 60. So after it finishes logging all these little healths, it's going to say it's done. And now we can configure that. So we can do the same thing here. Easy to mock this, easy to mock this, easy to mock this. And now we can say, all right, it's going through the choice. It went down the default path, which means that the target had HP left, and now it's going to go through a for each. So what we want to do is we want to say, all right, we know this hero, when it attacks the villain, is going to give that back an attack result with 60 HP. And if it does it once for every HP, then we can say, all right, I want to verify that this was called exactly 60 times, because it should be done it for one for every HP. We can say next, finish that, and now you have a very easily recorded test. And I can run this. And note, this is one of the beauty of MUnit 2. You can ignore one test, you can ignore multiple tests, you can only run one test at a time. It is much easier to test like this than to go deploy your code and just start calling endpoints.
Hey, Jared, it's 10 till the hour. How are we doing on time?
This is the very last thing.
Awesome.
I'm not sure why it failed parsing that XML. I'm going to go ahead and remove the other tests just in case I accidentally did something to them. And there we go. That succeeded. And we didn't make any calls. And we didn't have to do anything manually. We were able to test that the 3 calls work all correctly, and the verification for how many times it logs, all without doing anything but clicking at max maybe 10, 12 buttons. That seems like a way easier way to get into testing than setting all this stuff up yourself. Because while all this stuff is very helpful, it's tedious. That is the end.
Awesome. All right. So Jared, thank you once again for the very detailed walkthrough on MUnit tonight. And again, thanks again for attending all the meetups you have. And of course, please provide feedback. We would appreciate it.